Good morning. Our lesson that we're looking at here is lesson 9.3, transformations on quadratic functions. So this is mainly for you guys that were not here on Thursday. I tried to record the lesson while I gave it on Thursday, but something went wrong and it captured the video but no audio. So this is take two for me through this. The people that are in class today are going to be working on a Desmos activity that kind of pairs with this lesson. And once you get done watching this video, then you can move on to the Desmos lesson. So we're going to be looking at transformation. A transformation is just making a change. You know that you can change things. When you transform things, you change them. So we're going to look at different types of transformations. The first kind we're going to look at is a translation. And the second type of transformation we'll look at are dilations and reflections. Vocabulary that we'll look at for this one, transformation just means change. Specifically, when we talk about a figure or a graph, we're going to be talking about parabola. That's the quadratic shape that we are graphing here right now. So when you see the word figure, talking about a parabola. Translate just means move up, down, left, or right. So it doesn't change the shape of the parabola or what it looks like. It just changes its position on the graph. A dilation, though, will make the graph either wider or narrower. And by that, if we have our regular parabola that looks kind of like a U shape, if we make it narrower, then it stretches it out vertically and it makes it narrower. Whereas if we make it wider, it would widen it out like that. So we'll look at what changes we have to make to an equation to make those type of changes to the parabola. We'll also talk about reflections. I think we'll find that to be the easiest one because we're used to that one. We know how to flip a parabola upside down already. Okay, so we'll just get into the specifics. First, we're going to just kind of refresh our memory about the parent function. Parent function is y equals x squared. Sometimes, a lot of times through this lesson especially, they replace that y with f of x. So f of x equals x squared, and it's the same thing as y equals x squared. We've talked about that before. The parent function is just that most basic parabola that we can put on a graph. Everything else that we do today are going to be transformations of that parent function. So we'll start out with the idea of where the parent function would be and what are we changing about the equation and how does that change move or change the shape of that parent function. So let's look at our first transformation. We're going to first look at translations. Translations just moving that function, moving that parabola. And specifically here with this first translation, we're just going to talk about moving it up or down. So we're just changing where the vertex of the parent function is. Parent function will always go through the origin. That's the kind of the spot where the parent function will always go. And if we're translating it up or down, all we're doing is changing where on the y-axis the vertex is going to fall. And we're going to use the constant k for that. So we're going to use the letter k in our equation. And by the end of the lesson today, we're going to have a new formula that we know, a new type of equation, a new formula. And the letter k is going to stand in that formula as moving our vertex up and down the y-axis. Okay, so when we add to the parent function, we're going to move up the y-axis. When we subtract from the parent function, we're going to move down the y-axis. All right. So when we look at this, describe how the given function will transform the graph of the parent function. So when I look at this, I recognize that I have my parent function, f of x equals x squared, but I'm adding 3 to it. And if I'm adding 3, that tells me that I'm going to move up 3 units. That's the way we want to think about it. We notice that this tells us we're moving, the whole parabola goes up 3 units. And so we can see that by, just taking the parent function and it would move it up 1, 2, 3 units. That's all it would do. So it would look like that. It didn't change the shape, didn't change the orientation on the screen, just changed dislocation. All right. This has a different k value here in the equation, and this k value is minus 2, so this one tells me that we would move down 2 units. fairly simple to see what's going to happen here. I'm recording for my algebra. Okay, so we've got the parent function, and the minus 2 moves down 2 units. Okay, so that's all that happens when we have this. X squared is our parent function. If we add to it, if we subtract from it, that just moves it up or down the y-axis. Okay, next, that's not the only type of translation that we can make, though. Translating up or down is one direction, but we also have to be able to translate horizontally. So we can move left or right on the graph by using the constant h. And notice that it's going to look a little different this time, okay? We've got x being where we would expect it to be in our function, but before we square it, we're going to add or subtract h. And this one is a little bit confusing because you have to think of it this way. The formula calls for us to subtract h. That's the formula, x minus h squared, okay? But here the definition tells us that if x is greater than 0, the graph goes to the right. So if x is if h is greater than 0, the graph moves to the right. If h is a positive number, so think about what happens when you subtract a positive number, okay? If you subtract a positive number, it's moving to the right. But if we subtract a negative number, it's going to move to the left. If h is less than 0, the graph moves to the left. That is, if you subtract a negative number. Well, what happens when you subtract a negative number? So if we have this right here, x minus negative 3 squared, well, that's going to tell me that my graph, because x minus negative 3, it's going to look like this. It's going to look like x plus 3 squared. And so if I'm actually adding a number, then I'm moving to the left. But if I'm actually subtracting another number, then I'm moving to the right. Okay, so we got to be careful with that. That's, I think, one of the more confusing aspects of the formula. But once you've seen it a few times, it should make sense. So look at these examples. In this case, x minus 2, since minus a positive number would actually be x minus 2, this would be a positive 2, which means I'm moving my parabola 2 units to the right. Okay, so a x minus 2 is going to move the parabola 2 units right. 1, 2. So that's my first one. That's g of x equals x minus 2 squared. Okay, this one is plus 1, but since to get a plus 1 out of an equation that has a subtraction in it, it must have been subtracting a negative 1. So this one tells me that I need to move my parabola 1 unit to the left. Okay, so those kind of all run together there. It's hard to see, but hopefully you're seeing what the equation does. When we subtract a number, we're moving to the right. When we add a number, we're moving to the left. Okay. We can make horizontal and vertical translations at the same time. And so this is the cool part. Hopefully this is where you start to see some connections here to things that we've done in the past. So if I have this plus 2, this is my k value. K is plus 2. That means I want to go up 2 units. This one is a positive 3. Think about it. I'm subtracting a 3, so the 3 must be positive, which means I move to the right 3 units. So I'm going 3 units right, 2 units up. Okay, so, 3 units right and 2 units up would be right there. Well, we need to think about what we've just done here. So let's think about where I've moved it. I started out with my vertex on the origin. I moved it 3 right and 2 up. So look where my new vertex is. My vertex now is at the ordered pair 3, 2. So the equation in this form, the equation itself gives me the vertex of my parabola. That is really handy. Think about all the work that we've done graphing things up to this point. And if we can have a form of the equation that tells us the vertex, that's going to make life really, really simple for us to graph these things. Okay, so the vertex is in the equation. So think about that, what that means for this one. This one, my h value is this is going to be h minus, or x minus h, which is x minus negative 3. That's how we got a plus there, which means I need to go left 3 units. And this one is going to be minus 1, so that's down 1 unit. Okay? So left 3, down 1. Left 1, 2, 3, down 1. And look at where my vertex is. My vertex is at 1, 2, 3, down 1. So my vertex is at negative 3, negative 1. The equation, once again, has told us where the vertex of the new parabola is. That's really, really exciting for us, guys. It's really handy for us to be able to know the vertex just from the equation, because that makes graphing the equation very, very simple. All right. We don't just have translations, though. We don't just move parabola left and right and up and down. We also can change the shape of the parabola to some extent when we change another constant in the equation. And this constant is going to have the letter A, which is exactly what we're used to having. We're used to having an A. H and K are both new variables for us, but A is the same variable we've been using when we put an equation in standard form. It's that leading coefficient. So here's the kind of the definition of what's going on. If the absolute value of A is greater than 1, so A is bigger than 1, then the graph of f of x equals x squared, that is the parent function, is stretched vertically, and that's this red one here. The blue one is our parent function. The red one has been stretched vertically. It gets narrower, it gets longer as you move up, right? But if A is in between 0 and 1, so if A is a decimal or a fraction, then the parent function is compressed vertically. It's like it's squished. It's kind of pushed down. So this one, this green one, is being spread out wider, okay? And we're going to see that at work here on the next page. So let's graph these two parabola. We already know that our parent function goes through the origin, and because this one has not been given an h or a k value, it's going to have a vertex at the origin the same as the parent function does, because it's not been translated anywhere. This one has been translated 3 units down, so it's going to actually have a vertex that's down here. But this one has a vertex through the origin. Now, earlier this week or last week, we've talked about how to draw a parabola. And when we don't have any changes being made to the parabola, when it's just the parent function like this, we should remember the pattern. The pattern is over 1, up 1. Over 1, up 1. And that's the first, that gets us to our next spot on the parabola. The next spot is over 1, up 3. This is just the parent function we're doing right now, over 1, up 3. So the parent function goes like that, and then our next one would be over 1, up 1, 2, 3, 4, 5. Okay? So over 1, up 5. That gives us the parent function. See if I can do this or not here. Not too bad. Okay. Tough to do with this thing, but I made it. Now, if we so that's the parent function. We want to talk about how this affects the parent function. What does this do to the parent function? Well, this one cuts the growth rate in half. And so this one is growing at a rate of just 1. Think about the parent function, y equals x squared. Our a value for this one, a equals 1, right? Well, this one is a equals 1/2. So our growth rate of the function is going to be cut in half. So we're still going to go over 1, but instead of going up 1, we're going to cut that in half. Instead of going up 1, we're just going to go up 1/2. You're going to go over 1, up 1/2. Okay? Our vertex is still at the origin. Our next one for the parent function would be over 1, up 3, but this time we're going to go over 1. Instead of going up 3, we're going to go up 1.5. We've cut that growth rate in half. So instead of up 3, we're going to up 1.5. Okay, and then the next one, we would have gone over 1, up 5, but instead of going up 5, we're going to go up 7.5, right? Not 7.5, sorry, 2.5. I'm thinking about where it might have ended up. So over 1, up 1, 2.5. That halves the growth rate. So over 1, up 1, 2.5, right there. That is the graph of y equals 1/2 x squared. Oops, glitched. There we go. Okay, not too bad. So we see that compared to the parent function, this new parabola is wider. It's been compressed vertically. It gets squished down a little bit, and its growth rate is slower because we've got a fraction in our A spot. So let's look at this one then. Switch colors again here to a new color. And this one has an A value of 2. So this one's going to grow twice as fast as my parent function did. Where my parent function grew 1, this one's going to grow 2. Where my parent function grew 3, this one's going to grow 6 because the growth rate is doubled. Okay, so, but this one also has a vertex shift. We have a translation of -3. So we're going to put our vertex at down 1, 2, 3, right there. Okay, so I would go over 1. The parent function would go up 1, but this one's going to go up 2 because we're doubling that growth rate. So over 1, up 2. The parent function next would go over 1, up 3, but this one's going to go over 1, up 1, 2, 3, 4, 5, 6. Kind of hard to see. It's running into the other one. So over 1, up 6. And I can't even get the next one on there because the next one for the parent function would go over 1, up 5, which means this one would go over 1, up 10, which would be up here off of my graph, right? So that's where that one would be. So this parabola has been stretched vertically. It's going to be a much narrower parabola, much taller parabola than my parent function. Okay, so you need to think about what that A value is doing. It's either slowing the growth rate by putting a fraction in front of it, which makes it wider, or it's speeding up the growth rate by putting a whole number in front of it, which stretches it out, which makes it much narrower and much taller. Okay, the other type of, we'll talk more about that in just a second. Okay, so a quadratic function written, so these are the new variables that we've learned today. We've learned about A, which gives us that either vertical compression or vertical stretching of the parabola. We've learned about H, which shifts our parabola left or right, so it's a horizontal shift to the parabola. And we've learned about K, which is a vertical shift, so it's a either up or down shift to the parabola. And this is vertex form, so f of x equals A times x minus h squared plus k. That is vertex form, and we want to be able to look at parabola and be able to find the vertex and find the shift based on what we see on the parabola, or we want to look at quadratics that are written in this form and be able to graph them very quickly based on what we're seeing with the vertex and the change in shape. Okay, so this is the summary of all the stuff that we've just looked at in this lesson. H gives us our horizontal translation, left or right. K gives us our vertical translation, up or down. A gives us our dilation, so we're either stretching it out, making it wider, or we're making it narrower, stretching it out, making it taller. So we're either stretching it vertically or compressing it vertically. And then the thing that we didn't really talk about, but we have talked about before in the past, you know that if A is negative, then it's going to flip it over. So we can do all these same things to our parabola upside down. We can turn it upside down with a negative A value, and then we can still stretch it or compress it. We could still move it left or right based on our H and K values. Okay, so I feel like I should have stuck a couple more examples in here for us to work through some stuff, but that's what the Desmos is for. So if you guys are ready, done with this, taking all your notes, then you can move on to the Desmos activity and try to visualize what the equation is doing based on the location of the parabola on the graph. All right, thanks guys, and I'll be back Monday. Monday we will go over, we probably will spend some more time on that Desmos and talk about just a few of the shapes and stuff, though it won't be our entire activity for the day on Monday.